Today we're going to do a brief overview of trig equations. First, what is a trigonometric equation? Well, it's simply an equation that has a trig function. So what does that look like? So that means it could look anything like 2 sine x plus 1 equals 0, or you could have something like sine squared x plus 2 cosine equals 3. Both would be examples of trig equations. Alright, solving trig equations. Well, we're going to use similar techniques just like we did in Algebra 1 and Algebra 2. So the first thing we're going to have to do is we're first going to have to isolate the trig function. After we isolate the trig function, we're simply going to use the definitions for each trig function and look to the unit circle for our answers. Now remember, when we're solving these trig equations, we are solving, our answers are going to be angles. Okay, so we're trying to find the angle that is going to make the statement true. Alright, let's look at a couple of examples. First thing, you're going to need a copy of the unit circle with you in order to solve these problems. So first, notice we want our answers between 0 and 2 pi. So we need to make sure that all our answers are going to be positive. And remember, our answers are going to be in radian form. So let's look at A. It's saying, where's the sine equal to 1/2? So basically what this is saying is, where is your y value equal to 1/2? So if I look on the unit circle, where's my y value 1/2? So if I start at 0 and go around, well, my y value is 1/2 at pi over 6. I continue going around. It's also, your y value is also 1/2 at 5 pi over 6. So theta is going to equal pi over 6 and 5 pi over 6. Now for B, for tangent, tangent's a little bit harder, because tangent is y over x. So this is saying, where is my y over x equal to -1? Well, this is harder to see because it depends on your y and your x value. So instead of looking right away at your unit circle, we're going to use our calculator. So remember, when we're solving for angles, you're going to take the inverse. So I'm going to take second tan, or the inverse of tan, of -1. If you enter that in your calculator, you're going to get -45 degrees. But remember, we wanted our answer between 0 and 2 pi, so we want this number to be positive. So we're going to find a coterminal angle. So we're adding 360, so we get 315. Now we're going to go to our unit circle. Well, 315 is equivalent to 7 pi over 4. So my first answer is 7 pi over 4. Now this only works for tangent, but to get our second answer for tangent, you're going to go diagonal. If you go diagonal from 7 pi over 4, I'm going to be at 3 pi over 4. So in this case, alpha equals 7 pi over 4 and 3 pi over 4. Alright, last one. Notice right here I have secant equals -2. Well, we want to try to rewrite everything in terms of sine, cosine, and tangent, so that way we can just look at the unit circle. So secant goes with cosine, so I'm going to rewrite this in terms of cosine. So if secant's -2, the cosine, you're just going to take the reciprocal of -2. The reciprocal of -2 is -1/2. Now cosine is my x value, so it's saying, where's my x value -1/2? So where is that true? Well, that's going to be true at 2 pi over 3 and also 4 pi over 3. So alpha equals 2 pi over 3 and 4 pi over 3. I want you to go ahead and try the remaining 3 problems on your own. So I want you to pause the video. Once you work all the problems out, play the video back and I will give you the answers. So theta is going to equal 5 pi over 6 and 7 pi over 6. For part E, remember we wanted to change cotangent to tangent. So if you do that, you're going to get tangent equals 3 over radical 3. So if we enter that in our calculator, second tan of 3 over radical 3, we are going to get 60 degrees, which is pi over 3. I go diagonal to get my second answer since it's tangent, and you'll get 4 pi over 3. And then for the last one, F, it's cosecant, so we're going to write it as sine. So I take the reciprocal. Now in this case, you have to rationalize the denominator. When you rationalize the denominator, you're going to get square root of 3 over 2. So where's your y value? Square root of 3 over 2. Well, that's true at pi over 3 and 2 pi over 3. If you have any questions on this, please make sure you stop by before school at break to get your questions answered.